Okay, just a little refresher on determining the x and y intercepts in the Cartesian coordinate system. Okay, now for the x-intercept, that by definition is going to be the location where the graph touches or crosses the x-axis. And in the case of equations given in terms of x and y, if we were to determine the x-intercept from an equation, we'll be looking at setting y equal to 0 and solving for the intercept value x. And in the case of the y-intercept, okay, you have a bit of a role reversal. Okay, you have the y-intercept will be the location where the graph touches or crosses the y-axis, and in an equation that is expressed in terms of x and y, to determine the y-intercept from an equation, we'll be looking at finding out what the missing value y is going to be, and that will be done as we set x to 0. Now, just a couple of quick examples that we have with regard to determining x and y intercepts. Now, one case could be where we have a linear equation such as 3x minus 4y is equal to 12. And again, now for the intercepts, okay, now again you have for the x-intercept, the general coordinates will be x, 0, and we have for the protocol, once again, we'll be looking at solving for x as we set y to 0. So for 3x minus 4y is equal to 12. Okay, we have 3 times x, where we're solving for the missing value x, and y is going to be set to 0. Okay, now 4 times 0 is 0, and 3x minus 0 is going to give us 3x, and we have that 3x is equal to 12. And as we look at solving for x, which we can do in one step, and that is the operation of division. Okay, so as we divide on both sides by 3, we had the missing x value to be at 4, and that is going to be the unique solution in the case of x. So we have an x-intercept which will be located at 4, 0. As for what we have in the case of the y-intercept, again, role reversal in terms of what to solve for, as well as that which we will set to 0. Okay, we had the same equation. Now we are solving for y, as x this time will be set to 0. So we have this time around, we have 3 times 0 minus 4y is equal to 12. And we have 3 times 0 is 0. And 0 minus 4y is going to be negative 4y. Okay, so we have negative 4y is equal to 12. And we have this time around with division. By negative 4, we have negative 4y over negative 4 is going to become y. 12 divided by negative 4 will be negative 3. So we had the missing value y to be at negative 3, and so we have for the y-intercept that is going to be at 0, negative 3. And we can supply a couple of additional points that will belong to the line representing 3x minus 4y is equal to 12. Okay, so we have we can pick arbitrary values for x. So we can say that for an additional point or two, say that if x, so we have the x is equal to 8. We have in this one, okay, we'll say that we have 3 times 8 minus 4y is equal to 12. 3 times 8 is 24. Minus 4y is equal to 12. And in looking at this time around, okay, we have x at 8, and for the corresponding value in y, okay, we can take away 24 from both ends, isolate the y term. Okay, so here we have 24 as a cancel, and so we are down to negative 4y is equal to negative 12, and we have with division that missing value y is going to be at 3. Okay, so we have an additional point to be located at 8, 3. And there's some other points that you can also throw in the mix. And now, so we have three points. Okay, so we have our intercepts. The x-intercept is at 4, 0. Y-intercept is going to be at 0, negative 3. And we have an additional point to be at 8, 3. And just setting up what we have for the ordered pairs in table form. Okay, so you have 3x minus 4y is equal to 12. So you have among the ordered pairs, you have the x-intercept. We have x at 4, y is at 0. And the y-intercept will be whenever x is set to 0, where we had the order pair at 0, negative 3. Again, we had an additional point at 8, 3. And if you were to supply yet another point, that could be, say, like taking a value of x and y, where we can have the solutions given in terms of integers. Say, like we have x at negative 4. Like 3 times negative 4 is negative 12. If you add 12 to both ends and solve for y, your y value is going to be at negative 6. And in terms of the appearance of the graph of 3x minus 4y is equal to 12, okay, that is going to end up as a straight line. So you have among the ordered pairs, you have negative 4, negative 6. The y-intercept 0, negative 3, where it crosses, again, the y-axis. Then we have 4, 0. Okay, so that is going to be the x-intercept, so the graph here crosses the x-axis, and we have another additional point at 8, 3. And again, we have this straight line to consist of these 4 among infinitely many other ordered pairs through which 3x minus 4y is equal to 12 is going to pass. Alright, now we can have intercepts to affect not only linear expressions, but we can also have them to apply to nonlinear expressions. Now we are fresh off of looking at circles, and let's say that if you have a circle, okay, whose center is at the origin, and we have, let's say, the radius is going to be at 6. So we have x squared plus y squared is equal to 36, and so this equation defines a circle. Now in terms of the x and the y intercepts, okay, so we have for the x intercepts, again, we're looking at solving for x as y is set equal to 0. Okay, so we're going to set y squared to 0 squared as we are looking at solving for x. So you can see we have x squared plus 0 squared is equal to 36. 0 squared is 0. And we have that x squared is equal to 36. And you could take away 36 and solve by factoring. But also you can use what is referred to as the square root property of equality, and we'll go at that route. So we're looking at going from x squared to x. Okay, there are two values that will square into 36. One is going to be positive, and the other one is going to be the negative of the square root of 36. And so we're going to have two values of x. Okay, one is going to be the negative of the square root of 36, which will be negative 6. The other one is going to be positive square root of 36, which will be 6. And so there will be two x-intercepts and keep in mind, okay, that all ordered pairs are of the form xy. Okay, and so for the x values, again, y is set to 0, so the x-intercepts will be at negative 6, 0 and positive 6, 0 as we express in ordered pair terms. Now, and what we have with regard to the y-intercepts, there will seem to be a little bit of redundancy, but be careful in terms of how you place the ordered pairs. Okay, so this time x is going to be from x squared plus y squared equals 36. X is going to be set to 0. Y will be that which we were looking at solving for. So this time around we're going to have 0 squared plus y squared is equal to 36. And so 0 squared is 0. Now we have y squared is equal to 36. And just like what we did in terms of solving for x, y, we'll be looking at, as an option once again, taking the square root property of equality, whereupon we're going to have y is equal to plus or minus the square root of 36. And we have for the values in y, we're going to have these to be at, once again, -6 and +6, like what we had for x. And this time around we have for the y-intercepts, remember, all ordered pairs are of the form x, y, and at each y-intercept your x value is going to be at 0. So we have for the y-intercepts, okay, there will be two of them. One is going to be at 0, -6, and the other one is going to be at 0, 6. And so for the outcome in this one, again, we have a circle that is going to be centered at the origin. And so we have, once again, we have for the y-intercepts, we have 0, 6, 0, -6, where the circle crosses the y-axis, and then we have -6, 0, 6, 0, our x-intercepts, okay, whereupon the circle is going to cross the x-axis. Okay, and so we have for the circle again, we have this to feature the characteristics of the expression x squared plus y squared is equal to 36.